So hi everyone. So today we are going to discuss about the concept of singly linked list. So singly linked list is nothing but when number of nodes are connected by a unidirectional link. So first we should know what is node. So node is nothing but it contains two parts. So first part contains the data to store a value, and the link part to store the address of next node. So this part, the link part only decides which node is going to be added next to this current node. So now the implementation of a singly linked list. So first thing, so what you have to do is, so we need to create the structure of this node. So we are going to implement using C. So struct node, and we know that node contains two parts. So one is data and the other part is link to store the address of next node. So first we have to declare the data part. So we are going to store a value only. So we are declaring the data type as integer, and we take the variable name as data, right? So next we are going to store, that means we are going to declare about the link part. So for that here we are going to store the address of a node. So we have to define with struct node star. So I am declaring the variable name as next. And to access this data part and link part, so we need some structure objects. So we are going to create the structure objects at the end of the structure. So the first, we are going to use few pointers. So these are all the pointers we are going to use in our program. So why the term used first and last means, so instead of using the head pointer, we are going to use this first, because these two pointers, one is going to define the first and last node of the list, and we are going to use these temporary pointers like pointer previous in our program. So I declare the pointers at the end of structure itself. Okay, so next we need to allocate memory for this node which we create. So for that I am going to use a separate function called create. So I am going to allocate memory for this new node. So name of the pointer is new node, and I am going to allocate memory for this new node during runtime. So struct node star. So I'm going to allocate memory. So when means during the execution time. So for that we are going to use a function malloc. So based on the size of the node which we create at the beginning of this program. So we are going to allocate memory during runtime. So based on the size given in this node part. Okay. So now the memory has been allocated for this node. So next thing, we need to assign a value to the data part, and we have to assign initially the link part as null. So that is what we are going to do next. So first we need to get the value for this data part. For that, we are going to use a statement. So enter a value. So we are going to get the input for this variable. So here we are going to store a value only, so that belongs to integer type. So we use %d and ampersand. So here only we are going to store a value. So name of this node is new node. So here only I am going to assign a value. So new node. So in which part we are going to store a value. So here we are going to store the value for this data part only. So new node and the data. So since it is a pointer variable, so instead of the dot membership operator, we use this pointer to member operator. And after assigning a value to this new node, so next thing is we need to assign the next part as null. So for that, directly we use a statement, a new node, and the next part of new node is null. So that null pointer will be allocated assigned for this new node, right? So at the end of this function, I am going to return this new node. Return of new node. Okay, so one thing I have left out, so which means this one. So I didn't use any return type for this function. So at the end of this function, we are going to return node. So if it is a normal variable, we have to use the concerned data type as the return type. But here we are going to return entire node. So instead of using the normal data type like integer, float, or some other data types, so here we are going to return a node itself. So we have to use structure itself a return type. So structure node star create. So this is how we have to allocate memory for the node. So at the end of this function, simply I am going to return it, because whenever we call this function create, so we'll come and allocate the memory for the node, we'll assign a value, finally at the end of the function we'll return a new node, right? So next, the list of operations we are going to do in linked list is insert and delete. Okay, so insert, so we can insert a node at the first position of the list, or we can insert a node at the end of the list, and we can insert a node at the given position. So in insert operations, we are going to implement all these operations. So first we are going to insert a node, so at the first position of the list. So name of the function is void insert first. Okay. To insert a node at the first position, first thing is we require a node. So for that, already we have defined a function to allocate memory for the node, at the same time to assign a value, right? So here we are going to call that create function is equal to create. So what will happen? So compiler will call this function, will allocate memory for the node, and will assign a value. Finally, at the end of the function, we are going to return that new node. So after returning it, we'll come to this function and we'll assign to this variable new node. Okay, so here we are going to perform the operation insert first. So before insert a new node into the list, so the first thing what you have to do is we need to check whether the list is empty or not. So if okay, so already we have mentioned a pointer, two pointers, first and then last. So these two pointers define, so presently the list is empty, because so these two variables are already initialized as null one. So which means presently the list is empty. So that is what we are going to check at the very first condition. So if first equal to null. So if this condition is true, that defines the list is empty. So when the list is empty, we are going to assign the node which we get initially, we are going to assign as first node and then last node. So when the list is empty, assign first and last equal to this new node. Right? So after assigning this statement, so the list will be like this. So for just for example, if the value is 10 and already we have assigned the link part as null, so this new node will become the first node and then last node. Okay. Suppose if the first condition is false, which means the first is not equal to null. So the list contains some set of nodes. So automatically this condition will be false and will go to the alternative part, that means else part. So just assume that the list contains a node 10 and this is the first node and this is the last node, right? So now we are going to insert a new, again I am going to call the same insert first option, which means I am going to insert a new node at the first of this list, which means I'm going to insert a node before 10. So that is what we are going to do in this operation. So when we enter into this function, again we are going to call the function create. So simply I have defined this function for reusability. So whenever we require, we can call the function, we'll allocate memory for the node and we can add a value. So that is what we are going to do in this operation also. So when it comes to this position, again we'll call the function create, we'll allocate a node. Just assume that, so this is a new node. So I'm going to assign a value to this node is 20, just for example, and already the link part is assigned as null. Now we'll come to this function. First is equal to null, no, because already the list contains one node. So this condition will be false, and we'll go to the else part. We'll come to this part, and here I'm going to assign this new node in front of the first node, because the operation is insert first. So I'm going to insert this new node at the first position of the list. So directly we can convert this diagram itself into a code. That's what I'm going to explain next. So equal to operator, because the association of the equal to operator is right to left. So I'm going to use this logic to create a list. So first I'm going to assign this first node to the address part of the new node. Address part of the new node, so that link will be created and the address of first node will be assigned to the next part. That means address of new node. So now the link has been created. So after inserting this node, so instead of this node should be the first node. So I'm going to use the next statement as I'm going to assign this new node as first node. So automatically this node will be inserted at the first position of the list, and the name is also will be changed from new node to first node. So now after inserting this node 20 in the linked list, so this will become the first node and this will be the last node. So the next function we are going to say is insert last. So which means we are going to insert a new node at the end of the list. So already we have a list that contains a nodes 20 and 10. So this one is the first node and this one is the last node of the list. So now we are going to insert a new node at the end of the list. So here we are going to insert the new node, right? So again, to insert a new node, so the first thing is we have to call the function create. So new node is equal to, I'm going to call the function create. So the function will be called and will allocate a memory for this new node, and finally end of the function will return a node to this function. So now we got the node. Next we need to check the same condition if the list is empty or not. So for that we have a pointer first. So first equal to null. So if this condition is true, so as I said, the list is empty. So we have to assign the new node as first node and then last node. So assign the statement. So first and last equal to new node, right? Okay. If this condition is false, next time when we call the same function insert last, will come to this statement. First equal to equal, will come and check first equal to null. No, because we have two nodes in the list, so this condition will be false. Okay. Now we'll come to this else part. So here we are going to insert a new node at the end of the list. First we'll draw the structure. So node 20. So node 10, right? So this is first node and this is last node. So now just assume that, so this is a new node. Okay, so the link part of new node is also null. Just assume that the value is 30. So we are going to insert this new node at the end of this list. Okay, simply convert the structure into a code. first assign this new node to the next part of the last node. So assign new node to the next part of the last node. So when we assign the statement, so automatically the link will be created between the last node and then new node. Now the last thing what you have to do is we have to assign the new node as last node, because already we have inserted this node 30. So after this node 30 should become the last node. So assign new node as the last node. So just following these two pointers, just to trace out the first node and last node of the list. So after assigning this statement, this node will become the last node, right? So the node has been inserted successfully in the list. Okay, so now the list contains 3 nodes, 20, 10 and then 30. So next is we are going to insert a new node at any position, the user's given position. Okay, next, so we are going to see how we insert a new node at the given position, right? So as I said, so already the list contains 3 nodes, 20, 10 and then 30. So here we are going to insert a new node, so in between any position, right? So now the name of the function is void insert position. So here also before insertion, so we require a node and we need to allocate memory for the nodes. For that, I am going to call the same function create for this new node. So in the create function, so we'll use to allocate the memory and will assign a value to that node, and finally we'll return a node to this statement, right? So after retrieving the node, so again we need to check whether the list is empty or not. So again use the same condition if first equal to null. So in every insert operation we need to check this statement, because we have to ensure that the list is empty or not. Okay, so if the first node is null means, so obviously the list is empty. So we need to insert the same node as first position as well as in the last position. So assign first and last equal to this new node. So this new node will become the first node as well as the last node. Okay. Next, if this condition is false, because we know that the list contains 3 nodes, 20. So this is the first node, 10, and then 30, and this is the last node of list so far, right? So now I'm going to insert a new node, so in between the first node and then last node. So we have 3 nodes, 1, 2, 3. So before insertion, so we have to validate the condition. So which condition means we need to check the given position by the user is a valid position or not. So directly we cannot check. So first thing what we have to do is we need to count the number of nodes in the list, so that only we can decide whether the user input is a valid in position or not. So first part we are going to check the number of node count. So for that we are going to traverse each and every node of the list until it reaches the null pointer. So we are going to use a temporary pointer, so already declared in the structure, right? And I'm going to initiate from the first node. So assign first node to the pointer. So I'm going to initiate from the first node. You have to iterate till the last node is reached. So for that we are going to use a looping structure while, and we are going to validate whether the pointer is not equal to null or not, right? So if this condition is true, the list contains some positive nodes. So we'll enter into this looping structure. So before that, just initialize a variable. So int count equal to 0, right? So if this condition is true, just increment the count value because the node is positive one already. The pointer points to a node, so obviously this condition will be true. Which because it is not equal to null. Pointer points to the first node and it is not equal to null. So once if the condition is true, we'll enter into this looping structure and change the count value from 0 to 1 because I use post increment 1. So the count value will become 1, which means I have detected the first node and the count value has been changed to 1. Next, we need to change the position of pointer from the first node to the next node. So for that, we have to use a statement pointer next to the pointer. So obviously, the position of pointer will be changed from here to here. Now again, loop will be iterated and will check pointer is not equal to null or not. Again, the pointer is points to the node 10, so not equal to null. So the condition is true. We'll come to this looping structure and again the count value will be changed from 1 to 2 because the second node has been detected. Now again change the position of pointer from here to here so that pointer next is assigned as pointer. So the position of pointer will be here. Again loop will be iterated. We'll check pointer not equal to null. Yes, because the pointer variable is points to the node 30. Condition is true and we'll come to this statement. We'll increment the counter value from 2 to 3. Again change the position of pointer or next is assigned as pointer because now the pointer is next is points to the null one. So when it comes to this statement, pointer not equal to null, no, because the pointer reached the null pointer, so loop will be terminated. So now we got the number of nodes in the list, so then value is 3. Okay, after getting the node count, so we need to check whether the user input is valid or not. So first get the input from the user. So enter the position. Get the value from the user. Right? So after getting the position, we need to validate it. If the position should be lesser than the number of nodes in the list. So the node count contains the variable count, so it should be lesser than count because we are going to insert a new node in between first and last node. So that's why the lesser than operator is used here. So once if the condition is true, which means the user given position is a valid position, so we can proceed further. So after validating this statement, again we need to iterate to the respective position. So for that we require a while loop, but from where we need to initiate. So we need to declare the variable. Again first is assigned to the pointer because we cannot change the position of the first node. So for that we are using always a temporary pointer PTR. And now the first is assigned to the temporary pointer PTR. So we are going to validate this pointer only. So now pointer should be not equal to null. At the same time, so we need to check the position because we need to iterate through all the nodes in the list one by one till the position reached. So for that we require an initial variable. So I am going to initialize this variable as 1 just for the iteration purpose, and I am going to validate this. And the pointer should be not equal to null. At the same time, the value of I should be lesser than position. Okay, so if these two conditions are valid, we can proceed further. So now pointer points to the first node. So we have the list here. So now the pointer points to the first node and it is not equal to null. So the first condition is true and we are going to validate I is lesser than position. So for example, if the given position is 2, so the user input is 2. So value of I is, I am going to initialize the value as 1 and the position is 2. So the first condition is valid. So both pointer is also not equal null and the I value is lesser than the position. So now both the conditions are true. So if these two conditions are valid one, we can enter into this looping structure. So here I'm going to use one more temporary pointer because before we insert a new node, so 2, 3. So this is our new node. So I'm going to insert this new node so at the second position, right? So before we insert, we need to identify the previous node at the same time the next node. So then only we can insert this new node in between the previous node and then current node. So that is what we are going to do. So now these two conditions are true. So I'm going to assign one temporary pointer. So that is called previous to identify the previous node. So now I'm going to assign pointer to the previous. So now, so this is the first node and so this is the last node, and I'm going to already the first is assigned to the pointer 1. So now both first and pointer points to the same node 20. So when these two conditions are true, so I'm going to assign one more pointer previous to the one, this one. So now previous is also points to the same node 20. So once this variables is assigned, next thing is I'm going to change the position of PTR. So PTR next is assigned as PTR. Now the position of PTR has been changed from here to here, right? Now loop will be iterated again. So pointer not equal null. Yes, pointer points to the node 10 and it is not equal to null, and at the end of this loop we need to increment the position value of I also. So now the I value become 2 after the first iteration. So now this pointer is true but the value of I is 2 and the position is also 2. So this condition is false. So the loop will be terminated here. And then we got the position of previous also. Now we are going to insert this new node in between previous and then pointer. So just assume that we have an equal to operator in between the new node and after the new node. So simply we are going to convert this structure itself into a code one. Now we are going to assign new node to the next part of this previous node. So when we use this statement, the link will be assigned between previous and then new node because we have assigned new node to the next part of the previous one. So the address of node will be assigned to this address part of previous one. So the previous link has been assigned between new node and then first node. So next we have to assign the link between pointer and then new node. Now at the right hand side we have pointer. So after the equal to operator, use the variable pointer and I'm going to assign this pointer to the address part of the new node. So the right hand side link has been assigned between pointer and the new node. So now the new node has been inserted in between 20 and then 10. So this is how we have to insert a node at the given position. So once if the node is inserted, we need at the end of the function change the count value by 1 simply using a statement count plus plus.